Hello and welcome. We're going to do section 6.6, exponential and logarithmic equations. And the objectives are, of course, to solve exponential and logarithmic equations. So let's dive right in. With this first equation, there's a few ways we can do that, but probably the most efficient is to start by dividing by 2 on each side. So we get 17 equals 4 to the x. Now I'm going to flip this equation and write it as 4 to the x equals 17, because this is the way we kind of practiced doing this spiral thing. That is the same as saying log in base 4 of 17 equals x. And if you calculate with your TI Inspire, you would get x equals 2.044. If we are not in a calculator test, then writing that x equals log in base 4 of 17 is the expected answer. So how else could we solve this exercise? I'm just going to copy 34 equals 2 times 4 to the x. Maybe an idea after dividing by 2 would be to take the log in base 4 on each side. So log in base 4 of 17 equals log in base 4 of 4 power x. And log in base 4 cancels out with 4 power x, and we end up having log in base 4 of 17 equals x. So from here it's the same as on the first way we did it, and we get x equals 2.044. There's just one more way I want to show you. What about if someone decided right from the get-go to take log in base 4? Of course, log in base 4 is the only good choice, because you definitely want to cancel out this 4 power x. So the base is 4, and that's why you take the log in base 4 in order to cancel it out. So if we do that, we now have on the second line log in base 4, 34 equals, and we can use one of the properties of logarithms, which is that log of a times b equals log of a plus log of b. From there, we can subtract log base 4 of 2. So we would get log base 4 of 34 minus log base 4 of 2 equals log base 4 of 4 to the x. You could calculate the left-hand side with your calculator, or you can use another property, which is that this is equal to log of 34 over 2 base 4. So you can see how this has brought us back to the previous situation. And on the left, just like before, the log in base 4 cancels out with 4 to the power of x, and we end up with x. So that's one more way of solving. Either works, but I suppose the very first one here is the fastest, the most natural. The second equation is 3 to the x plus 1 equals 5 power x. I will show you first using logs. So what do we want to do? Maybe choose log in base 3, or log in base 5 is also an option, because we can see we have an exponent with base 3 and an exponent with base 5. Let's try with log in base 3. So I have to do the same on the right-hand side. And what can we do here? We can bring down the exponents on the right-hand side. On the left-hand side, even more valuable, log in base 3 cancels out with the exponent of base 3. So on the left we have x plus 1, And on the right, we use this property to write log x times log in base 3 of 5. So we've used, at this point, all the properties of logs. Up here, on the right, we had used log of a times b equals log a plus log b. Here we've used log of a over b equals log a minus log b. And right here, we have now used log of a power b equals b times log a. So, very good practice. What can we do from here? Well, we have to put the x's on the same side. So let's bring the x's on the right-hand side. 1 equals x times log in base 3 of 5 minus x. And that means we can factor out x. We have x times log base 3 of x, log base 3 of 5 minus 1. And therefore, x equals 1 over log base 3 of 5 minus 1. If you calculate the value, this is x equals 2.150 or 2.151 if you round up. There's another way that you could solve this exercise. It's a little particular, so I'm gonna do it, but it's less bulletproof than the method I just solved now. But it's worth seeing, because if you notice that in a test, it can be a little bit of a shortcut. 3 to the power of x plus 1 is actually 3 times 3 power x. And on the right-hand side, 5 power x. So the advantage of doing it like that is now I can write 3 equals 5 power x over 3 power x, which is 5 over 3 power x. And now I'm going to use log on each side, or I'm going to use this spiral thing. If I use the spiral, I need to switch the order. So 5 over 3 power x equals 3. But in any case, I get log in base 5 over 3 of 3 equals x. Well, it might not be completely obvious that this is the same as that, but I expect that it is. So there are many ways to solve these problems, but it's useful to see the different ways, to be a bit more flexible in a quiz or a test, or if you're reading someone else's work, you don't know which one they've chosen. Next problem, ln of x squared minus 16 equals ln of 6x. Now, if you focus here, you can probably notice that all we need is that this equals that. If this is true, then ln of the left-hand side or ln of the right-hand side is going to be the same. Otherwise, the other method is just to say, well, I want to get rid of ln, and the way to get rid of ln is e power ln of that equals e to the power of ln of this. And right from here, things cancel out, e cancels with ln, and we get what we noticed. X squared minus 16 needs to be equal to 6 power x. Basically, what's inside the parenthesis needs to be the same on both sides. So this is a quadratic equation. We're going to subtract 6x from both sides, and we can factor. This is x minus 8 times x plus 2. And so we find x equals 8 or x equals negative 2. Now you always need to check to see whether it works. If we check with x equals 8, we get ln of 64 minus 16, and we are wondering whether this is equal to ln of 6 times 8. Yes, it is, so we are good. But what about x equals negative 2? We have ln of x squared minus 16, so 4 minus 16, and right here we are stuck because this is undefined. So maybe last year in Algebra 1, solving equations, you never needed to check because the equations were linear equations and it was not too hard, but we now deal with some funky expressions, and it comes from the fact that the domain of ln of x, the domain of log of x, is not all real numbers, and that's why we need to check whether the equation works for the solutions we found. So this is not okay. The only correct answer is x equals 8. Lastly, we can use two methods here. Again, I'll do them quickly. Either you do the spiral, so 2 power 6 equals x cubed plus 37, or you say, I'm going to take 2 here and 2 here, so 2 power log base 2 on the left and 2 power 6 on the right, and that basically does the same thing. You end up with 2 power 6 equals x cubed plus 37. 2 power 6 is equal to 64. And so if you subtract 37 from both sides, you will get 27 equals x cubed, and so x equals 3. All right. How do we use our calculator to solve an equation that would be too difficult to solve by hand? Well, you look at each side of the equality and you set it as as a function. So we could deal with y equals log base 3 of x plus 5 and y equals 2 to the power of x squared minus x. What do these graphs look like? I'm going to make a rough sketch. One looks approximately like that, and the other one looks approximately like this. It seems with my sketch that they intercept exactly on the y-axis, but it's not quite right. So once you've graphed these on your TI Inspire, you need to click Menu, and it's button number 6 and then button number 4. And then you have to pick the range that you're interested in, and you're going to need to do that twice so that you hit both of these intersections. One is here and one is there. And you will get x equals negative 0.356188, and you will find x equals 1.509910, and so on. You really should try with your TI Inspire now to make sure that you obtain these two values. And you may wonder, what about the y value? Because we are looking at a graph, it needs to have an x and a y value, but look at the question. The question is purely an expression in terms of x. Y has nothing to do with the question. We kind of created a function in order to solve this problem, but y is irrelevant to answer the question. So the correct answer is simply x equals negative 0.356 and x equals 1.509. Lastly, a forest fire grows exponentially over time. Kevin, in charge of the fire department, declares they can contain a 160-acre fire without needing additional assistance. about how many minutes does it take for the fire to become too big. So it might be a little unclear whether we need to find an exponential model here using a spreadsheet and finding a best fit model, or if we can just use the first two data given and solve a system of equation. I'll make sure in a quiz or a test that it's more clear, but here we are going to focus simply on the first 2 points. So we have the point 0, 4, and we have the point 1, 7.2. And we are trying to find what exponential function, an exponential function of the form a times b power x, which exponential function satisfies these two conditions or goes through these 2 points. So if we plug in x equals 0, y equals 4, we find 4 equals a times b power 0. And if we plug in x equals 1, y equals 7.2, we find 7.2 equals a times b power 1. This is a system of equations. Luckily, it's not too hard because from here, I'll change color just because I finished the setup now. From here, this is 4 equals a. So we already found a. And if we plug it in the second, we can write 7.2 equals 4 times b, which leads to b being equal to 1.8. So we now found that y equals 4 times 1.8 power x. By the way, if you tried x equals 2, you would find this value here, and if you tried x equals 3, you would find that value there. Now I'm going to just change something because I noticed that we are given times in with the letter t, so I think it's better if I also use a t. So I'm changing this to t here and here. Y equals 4 times 1.8 to the power of t. So that's not it. We now need to answer the question, at what point would this fire be too big for the fire department to handle it? And it will become too big when y is 160. The fire will be too big when y equals 160 or more. So 160 equals 4 times 1.8 to the power of t, which means 1.8 to the power of t equals 40. And from here, you can use the spiral, or you can just think, okay, I'm going to take a log in base 1.8, and this leads to t equals log base 1.8 of 40. So the answer is 6.28 minutes. So that's it for the notes for this section. I hope it was helpful. Thank you so much.